So today we're looking at the first part of section 2.2, the standard form of a quadratic equation. At the end of today, you'll be able to write and graph quadratic functions in standard form. So let's review a little bit. The vertex, we're going to learn how to find the vertex of a quadratic function in standard form. So the standard form a quadratic function is f of x equals ax squared plus bx plus c, which is nice because remember yesterday, when we were doing vertex form, we expanded it out and wrote it in ax squared plus bx plus c form. So now you see that that expanded out version is known as standard form. So you're somewhat familiar with this already. Where a, b, and c are real numbers and a cannot equal 0, because if a equals 0, it is no longer a quadratic. So we want to use the vertex form to derive the standard form. Again, this is just what we had been doing in the previous lesson, okay, where we took the x minus h quantity squared, we did the shortcut, we multiplied it out. So we took the first term, we squared it, got the x squared, multiplied x and the negative h together, and then doubled it, negative 2xh, and then squared the h. Okay? And then it just says if you distribute your a with all of that and simplify, you get the ax squared minus 2ahx plus ah squared plus k. Okay? And then it tells you that a is equal to a, the b is the negative 2 times a times h, and the c is a times h squared plus k. Okay? So what we need to know about all of that. The vertex is still h comma k. The x-coordinate of the vertex is this formula. So this is the formula that we're going to use. H equals negative b divided by 2a. This is how we find the x-coordinate of our vertex. And then when we plug that back in to find the y value of our vertex. The axis of symmetry then is still x equals h. It's still that vertical line, so it's x equals the x-coordinate of our vertex, which is known as h. We are still graphing it as a dotted line. The y-intercept, okay, so the nice thing about if it's in standard form, just by looking at it, you can get your y-intercept. Your y-intercept is 0, c. So let's look at some examples. We're going to find the vertex, the axis of symmetry, the y-intercept, and then the maximum or minimum of the following functions. So number one, f of x equals x squared minus 6x plus 10. We're going to start out by identifying a, b, and c. So a is 1, b is negative 6, and c is 10. A is just the number in front of x squared, b is the number in front of x, c is your constant. So we're going to find h. H equals negative b. Remember, that just means change the sign of your b. My b was negative 6, so I changed it to positive 6. Divided by 2 times a, which was 1. So 6 divided by 2 is 3. So my vertex, I now know the x part is 3. Now to find the y part, I plug 3 into my original equation for all of my x's. So 3 squared minus 6 times 3 plus 10. So we get 9 minus 18 plus 10. So 9 minus 18 gives us negative 9. Negative 9 plus 10, 1. So our vertex is 3, 1. Our axis of symmetry, AOS, is x equals 3. It's the x value of the vertex. The y-intercept is 0, the c from our original function, that 10. And this graph opens up because it's a positive x squared, so we have a minimum at the y value of our vertex, which is 1. Now we're going to do the exact same thing on number 2, x squared minus 8x plus 5. Again, I'm going to start out, a is 1, b is negative 8, and c is 5. So find h. H equals, again, negative b. My b was already negative, so I just changed it to positive 8 divided by 2 times 1. 8 divided by 2 is 4. So my vertex I know is 4, comma. Now to find the y value, plug 4 in. So 4 squared minus 8 times 4 plus 5. So I get 16 minus 32 plus 5. So 16 minus 32, and then add 5, I'm at negative 11. My axis of symmetry is the line x equals 4. My y-intercept, 0, my c value, which was 5. The parabola opens up, so again, I have a minimum at my y-coordinate, negative 11. All right, let's look at number 3. Again, A is 3, B is negative 12, C is 40. We're doing the same thing, it's just our numbers are getting bigger now. So H equals positive 12, because I changed the sign of it, divided by 2 times 3. So 12 divided by 6 is 2. So my vertex is at 2 something. So plug 2 in, so 3 times 2 squared minus 12 times 2 plus 40. So 2 squared is 4 times 3 is 12 minus 24 plus 40. So 12 minus 24 gets me negative 12. Negative 12 plus 40 gives me positive 28. So my vertex, 228. My AOS, axis of symmetry, x equals 2. My y-intercept, 0, comma c, 0, comma 40. This parabola again opens up, so it's a minimum at the y value, 28. Right. Same thing with number 4. So identify A. A is negative 2. B is negative 16. C is 20. So find H equals, so my B again was negative 16, so I changed it to positive 16, divided by 2 times negative 2. So I get 16 divided by negative 4, which is negative 4. So my vertex, negative 4 something. Plug negative 4 in, so negative 2 times negative 4 squared minus 16 times negative 4 plus 20. So negative 4 squared is 16. 16 times negative 2, negative 32. Negative 16 times negative 4 is positive 64 plus 20. So 64 plus 20 gets me 84 minus 32 gets me 52. So my vertex is negative 4, 52. My axis of symmetry, x equals negative 4. My y-intercept, 0, comma 20. This parabola opens down, so now I have a maximum at my y-intercept, or sorry, my y value, my vertex, 52. Okay. Right, so now we're going to go to the next page. Now we're going to do the same type of thing, and then we're going to graph them. I mistakenly asked for the x-intercept on here. We have not learned that yet on finding the x-intercept in standard form, so we're not going to do that yet today. So again, I want to start out finding my vertex. So again, I know A is 1, B is negative 4, and C is 8. So I can say H is equal to 4 divided by 2 times 1. So 4 divided by 2 is 2. So I know the x value of my vertex is 2. I'm going to plug that in to find the y. So 2 squared minus 4 times 2 plus 8. So I get 4 minus 8 plus 8 gets me 4. So my vertex is 2, comma 4. My axis of symmetry then is x equals 2. My domain, remember that the domain of every quadratic function out there, negative infinity to infinity. My range, okay, this parabola opens up, so that means I have a minimum value at the y value of my vertex 4. Remember, range, you start with the smallest y value. Since this graph opens up, my smallest y value is at the 4, the vertex, so it's bracket 4 up to positive infinity. My y-intercept 0, comma 8. Okay, so now I need some points to plot, to graph this. Okay? I have 2 points right here, my vertex and my y-intercept. So instead of making our xy table with the transformations from the parent function like we did with vertex form, in standard form, we put our vertex 2, 4, and then my y-intercept 0, 8. And then I need to find the point that is symmetric to my y-intercept, because remember, I know that the parabola is symmetric about the vertex. Okay? Remember that all of my y values, okay, will be the same on both sides of my vertex, where it's symmetrical. So I know at 0, I'm at 8. So I ask myself, this was my vertex at 2. What did I have to do to a 2 to get to 0? Okay? I had to go back 2 units. So the symmetrical side, on the other side of the vertex, I would have to go forward 2 units. So 2 plus 2 gets me 4. I know my y value is still 8. So these are the 3 points that I can plot. So 2, 1, 2, 3, 4. Here's my vertex. Those are my points. Connect them, U-shape. And then we still want to plot our axis of symmetry and label it x equals 2. Let's do another graph just to make sure that we understand what we're doing. So again, I can list A is -2, B is 4, and C is 1. So H equals, this is the first one that my B was not negative to start out with, so I'm actually going to put -4 because I have to change the sign of B, divided by 2 times -2. So I get -4 divided by -4, which is +1. So my vertex 1, so this should be an easy one to plug in and find our y value, right? -2 times 1 squared plus 4 times 1 plus 1. So I get -2 plus 5, which is 3. My domain, -infinity to infinity. My range, okay, this time my parabola opens down because it's a -2x squared. So if it opens down, I know my smallest y value is -infinity. And then it comes up to the y value of my vertex, 3 in brackets. Axis of symmetry, x equals 1. X-intercept, we haven't learned that yet on these. Y-intercept, 0, 1. Since it opens down, it's a maximum at 3. Okay, my xy table, vertex in the middle, 1, 3. My y-intercept, 0, 1. And again, I'm looking for the point that's symmetric on the other side. I go from 1 to 0, it was just one spot. So one spot on the other side of my vertex is 2, 1. Plot these points. A little bit over 1, up 3. Oh, too much. Over 1, up 3. So there's my point. Let's see if I can erase that so it doesn't look like it's part of my graph. Okay. 0, 1. And 2, 1. So here's my parabola. Again, I need my axis of symmetry labeled x equals 1. All right, so that's how we graph in standard form. Next thing today that we're going to look at is interpreting a graph of a quadratic function, our word problems. And this is where the real world application comes in. So this one, it gives me the graph of the function equals -10x squared plus 700x minus 6,000. Shows the profit a company earns for selling headphones at different prices. It wants to know what is the maximum profit the company can expect to earn. We see this word maximum. Remember, anytime we hear maximum or minimum and we're dealing with quadratics, we're just looking at the y coordinate of our vertex. So all I need to do is find the y coordinate of my vertex. My A is -10, my B is 700, my C is -6,000. So it's just a lot bigger numbers here, but the exact same process that we were doing. So H equals -700 divided by 2 times -10. So I have -700 divided by -20. My negatives cancel, my zeros cancel, so 70 divided by 2, or half of 70, 35. So I know my vertex is at 35 something. So now I need to plug that in to find my y value. So again, we're going to have really big numbers. So -10 times 35 squared plus 700 times 35 minus 6,000. When we plug all of that in and work it out, we end up with 6,250 for our y value. So how we can interpret that in this problem, that our selling price of $35, so if they sell the headphones for $35, that's where they get, okay, so selling price of $35 gives the maximum profit, and that maximum profit is $6,250. $250. Let's look at one more word problem like that. This one deals with water balloons. It says a water balloon was thrown from a window. The height of the water balloon over time can be modeled by the function y equals negative 16x squared plus 160x plus 50. It wants to know what is the maximum height of the water balloon after it was thrown. Again, we see that keyword maximum, and we know that we are looking for the y-coordinate of our vertex. So again, identify A, B, and C. A is negative 16, B is 160, and C is 50. So find our vertex x-coordinate. So H equals negative 160 divided by 16 times 2. Negative 160 divided by 32. That's a negative 16 down here. So our H coordinate turns into 5. So my vertex is at 5 something. So now plug that in. So negative 16 times 5 squared plus 160 times 5 plus 50. When we work all of that out, we end up with 450. So my answer to this, okay, after 5 seconds, my x value was 5, so after 5 seconds, the water balloon is at its max height. Of 450 feet, which seems a little unrealistic that if we started out at 50 feet and we throw a water balloon up in the air, then it makes it to 450 feet. But that's what this problem worked out to be. So that is day 1 of standard form of quadratic equations. We'll look at day 2 tomorrow.